Okay, in this video I'm going to go over operations of complex numbers. Complex numbers are in the form of a plus bi, where a is the real part and bi is the imaginary part. So if I look at my first example, these are my real parts, the yellow, and the red parts are my imaginary parts. You want to add the real parts together and the imaginary parts together, like similar to the idea of like terms. So -5 and -2 make a -7. And then a -2i and a +4i make a +2i. So my final answer is -7 plus 2i. Now you can type this into I part. What you would have to do is you'd have to be careful with the parentheses. So you'd have to put this whole entire thing into parentheses and type I part. So you'd first do math num I part, and then this parentheses, the parentheses that comes with the I part, and then put this whole thing inside and then close it. So you'd have 1, 2, 3, 4, 5, 6 parentheses. Okay, with the next one, the only thing we're going to do differently here is it's subtraction, so we need to distribute the negative. So I'm going to have 3 plus 6i plus 6 plus 4i. I'm going to add the real, which is 3 and 6, to get 9. And I'm going to add the imaginary parts, which is 6i plus 4i, which gets you 10i. And again, you can type that into I part as long as you put this in parentheses. And again, you need to make sure that this is the starting parenthesis that I part gives you. This is a new parenthesis, and then minus a new parenthesis, and then close it again. The next example is multiplication. I'm going to do box method in order to do this. So 7 minus 6i and -8 plus 3i. Okay, so -8 times 7 is a -56, and a -8 times a -6i is a positive 48i. 7 times 3i is 21i, and 3i times -6i is -18i squared. I'm going to combine these because they're like terms, so it'll become positive 69i minus 18i squared. Now at this point you should know that I squared is -1, so I really have negative 18 times -1. So I'm going to keep this, and I'm going to make this a positive 18 now, because negative 18 times -1 is positive. And I can add my real parts now. And I'm going to put this in a plus bi form, meaning that I have -38 first, because -56 plus 18 is -38, and then plus 69i. So again, a plus bi form. The imaginary part comes second. Okay, so the next one, the first thing I must do is I must simplify the radicals so that there's no negative inside of them. So I'm going to reduce this to 2 minus 2i. The reason why it's I is because the negative comes out as the I and the 4 comes out as the 2. Plus 5 minus 3i. Again, the negative comes out as the I and the 9 comes out as 3 because the square root of 9 is 3. And now, just like the last problem, I'm going to add the real parts, which is 7, and I'm going to add the imaginary parts, which gets me a negative 5i. And again, you could type this into your calculator as long as you use I part. Another side note is that it is very important to reduce the radicals first, and it's really important in the next one because you cannot multiply these until you simplify the radicals and get that negative out of there. So this has to be 2i, -2 plus, this has to become 7i, because the negative comes out as an I and the 7 comes out because it's square root of 49. I'm multiplying in this one, so I will do box method. So -2 and 3 gets you -6. -2 and -2i gets you a positive 4i. 3 and 7 gets you 21i. 7i and -2i is a -14i squared. Okay. I will add these terms because they are like, so I get -6 plus 25i minus 14i squared Now again, I squared is negative 1. If you don't remember that, you can just type in I squared into your calculator and you'll get it. Negative 6 plus 25i plus 14. I'm going to add my real parts, which is negative 6 and 14. And negative 6 and 14 get you a positive 8 plus 25i. Again, you can type this into your calculator, the original problem. That would be useful for multiple choice, but you do need I part, and this has to be in parentheses. Now, just like square roots, imaginary numbers are not allowed to be in the denominator. So I am going to try to get the I out of my denominator here. Because this is a monomial, I'm going to multiply the top and the bottom just by I. And you should see what happens here. The top gets you 2i, and the bottom becomes 5i squared, which is good because we know that I squared is negative 1. And that allows me to get the I out of the denominator. Now with the next example, you should notice there's a binomial in my denominator with an I. So just like square roots, you don't want the I in the denominator, and just like square roots, in order to get rid of the I in the denominator, you multiply by the conjugate on the top and bottom. Now remember, the conjugate is just when you change the middle sign. You will multiply across and get your new fraction. You will do box method on this. If it was a part 2, you would have to show your work. If it was not a part 2, what is actually pretty cool is that you can type this whole top piece into I part and get your answer. But because there's no multiple choice here, we're going to do it out. So 1 times 3 is 3. 1 times negative 2i is negative 2i. 3 times 7i is 21i. And 7 times negative 2i is negative 14i squared. This will become 3. The negative 2 and 21i becomes a positive 19i minus 14i squared. And you should know that I squared is negative 1. And this now reduces to 3 plus 19i plus 14. And then these combine, and 3 and 14 get you 17 plus 19i. And that's my numerator. So I'm going to put that on my numerator, 17 plus 19i. And again, if you put this into I part with parentheses around everything, for the numerator, you would get 17 plus 19i. Now I'm going to do the denominator with my box method. Now what should happen in the denominator, because they're opposite signs, the I should cancel out. So let's see what happens. 1 times 1 is 1. 1 times negative 7 is negative 7i. 7i times 1 is positive 7i. And then 7i times negative 7i is a negative 49i squared. And if you notice, these do cancel. And I end up with 1 minus 49 times I squared. 49 is going to be times by negative 1 because I squared is negative 1. And I end up getting 1 plus 49 because negative 49 times negative 1 is positive, and you get 50. And that's your denominator now. So your whole answer is this. And again, you could have typed this whole thing into I part and gotten 50.